Bismillah ar-Rahman ar-Rahim. We'll start now this section 4.3. It's about increasing and decreasing functions and the first derivative test. We'll start. What's the meaning of increasing and decreasing? Yeah, what's the meaning of the main meaning of the basic meaning of increasing or decreasing? This is the basic definition. Before I go to the derivative, what's the meaning of increasing? Very simple. If you have a function, assume this function very clearly is increasing. So if you have x1, this will be f of x1. If you have x2 greater than x1, then we notice that f of x2 is also greater than f of x1. So the sign will not change. x1 less than x2. If you take two values, x1 less than x2, then still f of x1 should be less than f of x2. Decreasing, it will be the other way. If you go the meaning of decreasing, assume I have this, then you have x1, this is f of x1. But if I take, let me make it bigger like this. So if we take x2, f of x2 will be less than f of x1. F of x2, this will be f of x1, and that f of x2 will be less than f of x1, or if x1 less than x2, then f of x1 greater than f of x2. There's a change of sign between the x values and the y values. But if there is no change, I mean, x1 less than x2 means f of x1 less than f of x2, that means increasing. This is the basic definition. Now, when you connect it with the derivative, if you have a function continuous in the closed interval and differentiable in the open interval, then if f prime is positive over all x, for all x in that interval, then f is increasing. If f prime is negative, then f is decreasing. If f prime equals 0 for all x in that interval, then f is what? It's a constant function. Find the open interval in which f of x is increasing or decreasing. What I need to do, I need to find f prime, and then I will check the signs of f prime. So if you check f prime, very clear, that will be 3x squared minus 3x, which I can rewrite it. Yeah, it says 3x squared minus 3x. I can take 3x common factor. I have x minus 1. Yeah, so I have 3x squared minus 3x. That will help me to find, now to check the intervals where f is decreasing. I need to find when f prime, I need to find the critical numbers. So in this case, I need f prime equal to 0 because the function is differentiable everywhere. So that means x equals 0 and x equal 1. So now to check the sign of something, just I need to find the zeros of that function, and then I will split the number 9 according to these zeros. I'll check points now I have 3 regions, this region, this region, this region. I have 3 regions. I need to check a point in each region. So let me take a point, for example, minus 1. Take a test value. X equal minus 1. Plug it here. I have 3 times minus 1, minus 1, minus 1. I need to just check the sign. Very clear, the sign will be positive. Take a value here between 0 and 1. Take, for example, half. You can take half. It will be 3 times half. Half minus 1. That will be negative. This will be positive. This is negative. So the result is negative. Now take a value more than 1, 2. 3 times 2, 2 minus 1, that will be positive. I need just to be sure about the sign. So since it's positive, we agreed if f prime is positive, means the function is increasing. Negative, decreasing, and that will be increasing. So you can say increasing, which intervals? From minus infinity to 0, and from 1 to infinity, and decreasing from 0 to 1. Yeah, this is the basic idea. Now, when you have different functions, now we need to deal with it differently. Each function will give us, different function will give us different ideas. Now, so what's the guidelines to finding intervals in which a function is increasing and decreasing? If you have a continuous function, first we'll find the critical numbers. Then we determine the sign of f prime at one test value and each of the intervals. According to the critical numbers, we split the number line into different regions or different intervals. Then we'll find test value in each interval, and then we use the theorem 4.5, which is this theorem, to find determine f is increasing or decreasing. Yeah. As another example, find where the function is increasing or decreasing. The same thing, the function is differentiable, continuous. We have nothing to worry about. So f prime will be what? 12x cubed minus 12x squared minus 24x. Yeah, to find the zeros, I can take 12x common factor. I have what? I have x squared minus x minus 2. And that give me what? 12x. This I can factor it. X minus 2 times x plus 1. Yeah, is it? Yeah, minus 2x plus x is minus x. So everything is okay. Now to find the critical numbers, I will make f prime equal 0. So I have x equal 0, x equal 2, x equal minus 1. So I'll take the number line. I have minus 1, 0, 2. And this is my function. This is f prime. This is the function. We need to check the sign of that function. Yeah. So take a value in this region. I have 4 regions, 1, 2, 3, 4 regions. So take a value in my before minus 1, minus 2. It will be, this is positive, this is negative, this is negative, this is negative. Negative times negative times negative times positive, that will be negative. Take a value between minus 1 and 0, minus half. It will be negative, negative, then positive. Here it will be positive. Minus half plus 1 is half, so it's positive. So that will be plus. Between 0 and 2, take a 1, positive, negative, positive. So that will be positive. Negative, sorry. 1 will be what? 1, 12 times 1 times minus 1 times 2, so it's negative. More than 2, take 3. Positive, 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 so that will be positive. Yeah. So it will be decreasing, then increasing, then decreasing, then increasing. So you can say increasing from from minus 1 to 0, from minus 1 to 0, and from 2 to infinity, decreasing from minus infinity to minus 1, and 0 to 2. Yeah. So this is the basic idea. You just find f prime, find the critical numbers, split the number line. Now this is if you have a continuous function. Yeah, here's another example. Let us do it quickly. Yeah. So f prime will be what? 3x squared minus 3, which is 3x squared minus 1, which is 3x minus 1 times x plus 1. So critical numbers, f prime equals 0. So you have x equal plus or minus 1. Yeah. Like this, minus 1, 1. Take a value. Before minus 1, it will be negative times negative. That will be positive. Then it's negative, then it's positive. You can check it. Actually, if the power is odd, and the power is 1 and 1, then when you go to the 0, and for example, I have the power here is 1 and 1. So when I come to this 0, minus 1, I start, this is plus, minus 1, I need to change the sign. So that will be negative. The same thing here, since the power is odd. So that means that I need to change the sign. So very, very clear, increasing from minus infinity to minus 1, and from 1 to infinity, decreasing from minus 1 to 1, from minus 1 to 1. Yeah. Another example. Yeah, but now we are talking about a function which is not continuous. If you notice, this function is not continuous. So when I do the number line, I will find the critical numbers, not only that. And also I will divide the real line into at the critical numbers and the point of discontinuity. I need to find first the point of discontinuity and then find the critical numbers. Okay, so what are the points of discontinuity? Very clear. I have point of discontinuity, x equals 0, which is in the denominator. The 0 is in the denominator. Okay, now we'll find f prime. Okay, find f prime. Derivative of the numerator is 1 times the denominator, x squared, minus x plus 1, derivative of the denominator, which is 2x, over x to the power 4. So that give me what? That give me x squared minus 2x squared minus 2x over x to the power 4. In other words, that will be what? Yeah, minus x squared minus 2x over x to the power 4. I can take minus x common factor. I have x minus 2, correct? Over x to the power 4. In other words, it will be minus x minus 2 over x cubed. Over x cubed. Okay. Now we'll do the real line. I need to put what? Oh, now what will be the critical numbers? Huh? Let me find the critical numbers. I need f prime equals 0. So I have x equal 2. This will be the critical number. This is the only one because this is at x equals 0, it's not defined. If I check f prime does not exist, but the function, the domain of the function, all real numbers except 0. So 0 is not part. So critical numbers only x equal 2. But I will use 0 because it's point of discontinuity. So I have 0, open, this is not defined, this is 2. So this is my real line. I use the critical numbers, and the point of discontinuity. Now take a value. This is my function. You need to be careful. There's a minus sign, minus x minus 2 over x cubed. Take a value, for example, minus 1 will be negative over negative times negative, that will be negative. Between 0 and 2, take 1, it will be negative over positive times negative, so that's plus. Since the power is odd, there is a change in sign. More than 2, that should be negative. You can check it. Take 3, it will be positive times minus 1, so that will be negative. So I have increasing from 0 to 2 and decreasing from minus infinity to 0 and 2 to infinity. Yes. Consider this function now. Now we are dealing with trig functions, and then we'll deal with all the exams questions. Okay. Now I have, yeah, the function is continuous. We have no problem. We have a fixed interval. I mean a specific interval between 0 and 2 pi. So I need to find f prime to find the critical numbers as usual. Now this is, you need to be careful, the calculation, that will be 2 cosine x times minus sine x, derivative of cosine, minus 2 cosine x. So I can take minus 2 cosine x common factor of what? Sine plus 1. Sine x plus 1. Yeah. You can check, multiply, so minus 2 cosine x sine x, minus 2 cosine x. So this is correct. So I have f prime equals 0. I'm getting what? Cosine x equals 0 or sine x equal minus 1. Cosine x equals 0. What is the value? 1 cosine x will be 0, pi over 2, and x equals 3 pi over 2. Sine x equal minus 1, then x equals 3 pi over 2. Yeah. No. Yes, 3 pi over 2. Yes, correct. So it means I need only, this is 0, this is 2 pi. So I need pi over 2 and 3 pi over 2. Now between 0 and pi over 2, don't forget this is your f prime. This is my f prime, which I need to deal with. Take pi over 4 with the minus sign, huh? So I need to be careful when we do the calculation. Take pi over 4, it will be what? Negative. Cosine pi over 4 is positive. Sine pi over 4 plus 1 is positive, so this will be negative. Take a value between pi over 2 and 3 pi over 2. For example, pi, that will be negative. Cosine pi is minus 1, negative. Sine pi is 0 plus 1, so that's positive, so this one will be positive. Between 3 pi over 2 and 2 pi means in the fourth quadrant. So we'll take, for example, 7 pi over 4. That will be negative. This will be positive. Sine 7 over 4 plus 1, it will be positive. Yeah, since the maximum is minus, I mean, the minimum will be minus 1. So this will be, and it will not reach minus 1, 7 pi over 4. So this will be a positive value. So this is negative. So increasing where from pi over 2 to 3 pi over 2, decreasing from 0 to pi over 2, and from 3 pi over 2 to 2 pi. Okay, now let me do all the exams questions. Yeah, we need to do that. Now this is continuous, everything is okay. F prime will be what? 3x squared minus 2x minus 1. I need to factor this, so it will be 3x. Yeah, this is x. You need 1, so this will be minus 1, and this is plus 1. Yes, x minus 3x is minus 2x. Good. Critical numbers, x equal 1 and x equal minus 1 over 3. With the real line, minus 3, minus half, and minus 1 over 3 and 1. Take a value before minus 1 over 3. This is your function. This is my function, which I am dealing with. Yeah. Take a value, take minus 1. It will be negative, negative, so that will be positive. Between minus 1 over 3 and 1, take 0. It will be positive times negative. That will be negative. 1 more than 1, 2. Actually, since the powers are 1, there's a change of sign. 2, it will be positive for sure. So this is increasing, decreasing, increasing. He says decreasing from 1 to infinity. This is wrong. Increasing minus infinity to infinity. This is wrong. Decreasing minus infinity minus over 3, wrong. Decreasing minus infinity to infinity, wrong. Decreasing minus 1 over 3 and 1. Yes, here it's decreasing, so this is the correct one. So a different function you need to deal with. I have f prime will be what? Actually, we did something similar. Huh? We did it before. Is it the same function? 3x to the power 4. Yeah, exactly the same function, but plus 1, plus 5, plus 1. It will not make a difference. Let me do it again. 12x cubed minus 12x squared minus 24x. I take 12x common factor. I have x squared minus x minus 2. So that will be 12x times x minus 2, x plus 1. Critical numbers. This is my f prime. I need to check the sign. F prime equals 0. So I have x equals 0, and x equal 2, and x equal minus 1. Plug them. I have minus 1, 0, 2. Take a value before minus 1, minus 2. It will be negative. This is positive, negative, negative, negative. So that it's negative. Since the power is odd, so plus, minus, plus. What they want increasing. Increasing, it will be where? From minus 1 to 0 and from 2 to infinity. Which is this? The function is increasing in this interval. I'm trying to start with easy functions. So it will be f prime 12 minus 3x squared, correct? Yeah, which is what? We can take 3 common factor. I have 4 minus x squared. So that will be 3, 2 minus x, 2 plus x. Yeah, this is the function. Take it as is. Don't multiply by minus or something like this. So it will be f prime equals 0. That give me x equal 2 or x equal minus 2. So I'll put the number line minus 2 and 2. Okay. Take a value less than minus 2 minus 3. That will be positive. That will be negative. So that is negative. Minus 2 and 2. Take a value 0. It will be positive, positive. Yeah, change sign because the power is odd. This is negative. What he want? Increasing, increasing. It will be minus 2 and 2, which is this one. Yeah. The function, this is an easy function. That was term 231. F prime will be 3x squared minus 12x. So I take 3x common factor. I have x minus 4. This is my f prime. Critical numbers. F prime equals 0. So that means x equals 0 or x equals 4. Plug the numbers. This is 0. This is 4. Take a value less than 0, negative, negative. That will be positive. 1, positive, negative. That will be negative. More than 4. That will be positive. What he want? Decreasing. Decreasing means between 0 and 4, which is this. The function is decreasing in this interval. Before now we have just continuous functions. Now we'll try to deal with discontinuous functions. For example, this one, the domain of the function, all real numbers except 0. I have point of discontinuity, which is x equal 0. Now we'll find the critical numbers. F prime will be what? 1 minus 9 over x squared. In other words, x squared minus 9 over x squared. So f prime equals 0. So you have x equal minus 3 or x equals 3. Now when I put the number line, I need to put the point of discontinuity and these critical numbers. Okay. So I have minus 3, 0, open, and this is 3. Yeah, just to make sure it's a point of discontinuity. The function is not defined at 0. Because of that, I make it open here. Now, take a value between minus 3. This is my function. I can rewrite it also to make it easy for me to decide. Take a value minus 4. It will be negative. Negative. X squared, that always positive. So that be positive. Now, need to be careful about the power. Minus 3, what is the factor? X plus 3, the power is 1, so I change sign. 0, the power is even, so not change sign. That will be minus. You can check. If I took, for example, minus 2 here, it will be negative, positive, positive, so that's negative. Take 2 here. It will be negative, positive, positive, so that will be negative. More than 3, since the power is odd, I change the sign. So that will help. Okay, I want increasing, decreasing, decreasing, increasing. Can I say it's decreasing from minus 3 to 3? No, because at 0 the function is undefined. So the answer should be decreasing. You can say decreasing. Don't forget, it's not defined at 0. It's minus 3 and 0 and 0 to 3. I cannot say for minus 3 to 3. So where is the answer? This is the answer. Or you will see if there is another answer 0 to 3, you should have one of them. So both are correct, either minus 3 to 0 or 0 to 1. But you cannot see both of them as an answer. Okay. This function is decreasing. Now you have a rational function. So when you do the calculation, you need to be careful. First, what's the domain of f? All real numbers except 1. And we have point of discontinuity because they need it at x equal 1. Now we'll find f prime to find the critical numbers. Prime is what? 2x times x minus 1. Yeah, minus x squared, because the derivative of this is 1, over x minus 1 squared. So that give me what? 2x squared minus x squared. That give me x squared minus 2x. So I have x minus 2 over x minus 1 squared. Critical numbers, x equals 0 or x equal 2. So do the number line. I have the 0, 1 point of discontinuity. The function is not defined there, and 2. Okay, and this is my function. This is my f prime. Take a value, minus 1 will be negative, negative. This is always positive. So I have plus. Yeah, the power is odd, so change sign. When the power is even, so there is no change sign. That will be minus, and this is plus. Or you can take value. What they want, decreasing. Decreasing, I have what? Like what we did before, 0, 1, and 1, 2. You will see, you cannot see both of them. You can see one of them. So I have 0, 1, which is the correct one. Okay. I cannot say from 0 to 2. 0 to 2 is wrong, because that 1 is not defined. The function is increasing in this interval. Okay, we'll do the same. This is term 212. Okay, so the domain are real numbers except minus 1, point of discontinuity, x equal minus 1. So I'll find f prime, 2x times x plus 1 minus x squared over x plus 1 squared. So that'll give me x squared plus 2x over x plus 1 squared. That give me what? X times x plus 2 over x plus 1 squared. This is f prime. Critical numbers, x equal 0 or x equal minus 2. We'll do the real line. I have minus 2 and minus 1 undefined, and this is 0. Okay, take a value before minus 2, minus 3, negative times negative, that will be positive. This is always positive, so I have positive. Since the power is odd, I'll change the sign. Minus 1, the power is even, so I will not change the sign. Between 0, this is x, I have the power is odd, so I'll change the sign. Or you can take test values at each interval. So what they want increasing from where to where? From minus infinity to minus 2, and from 0 to infinity. So this is going to be my answer. Yeah. This function, same thing. Yeah, different function. We have different function. Okay. Now it's just a fraction. I mean, you need the quotient rule. So first you need the domain or real numbers except half. Or real numbers except half. So point of discontinuity, since the function is not defined, x equal half. Okay. Now we'll find f prime. Do the calculation. 2x times 2x minus 1. Yeah, minus 2x squared over 2x minus 1 squared. Yeah, that give me what? 4x squared minus 2x squared. That will be 2x squared. Yeah. That will be 2x squared. 4x squared minus 2. Yeah, 2x squared minus 2x over 2x minus 1 whole square, which is 2x times x minus 1 over 2x minus 1 squared. Okay. This is f prime. Critical numbers, x equals 0 and x equal 1. 1. So plug the numbers. I have 0, half, 1. Okay. I want to check decreasing. Okay, I need to check the sign. Before 0, take -1. Negative, negative. This is always positive. So I have positive, almost the same idea. The power is odd, so change sign. The power is even, I will not change sign. Minus. Power is odd, change sign. So this will be plus. I want the decreasing, like what we did before, like what we said before. It will be from 0 to half and half to 1. I cannot say from 0 to 1. So this is the correct answer, 0 to 1. Okay. Now we have different functions, so we need to deal with it. This is the function is continuous, but when you find the derivative, you need to be careful. I have 2x, x minus 9 to the power 7. This is product rule, function times function, plus x squared, or let me say 7x squared times x minus 9 to the power 6. I can take x common factor and x minus 9 to the power 6. What is the remaining? I have 2 times x minus 9. Okay. And here I have what? Plus 7x. Am I right? Yeah. You can check when you do common factor. Multiply this by this. I have 2x, x minus 9 to the power 7. Multiply this by this. We have 7x squared, x minus 9 to the power 6. Now, this is f prime. Or I can continue. X minus 9 to the power 6. This is what? 2x plus 7. That will be 9x minus 18. Yeah. I can take 9 common factor times x minus 2. That will be f prime. Critical numbers. X equals 0. This is 6. Yeah. I took the 9 out. X minus 2. Correct. Correct. And x equal 9 and x equal 2. These are critical numbers. Plug them. 0, 2, 9. Take the 0, negative, negative 1, negative, negative, negative. This is positive. So negative times negative, that will make it positive. Now change sign. This is change sign. 2 also change sign, but this is, I will not change sign. It's still minus. Yeah. Is it? What is this? Wait a minute. Take, this is 0. So this is, the power is odd, change sign, minus. And the power is odd, change sign, plus. Now the power is even, that it will continue as plus. Decreasing, or you can take these values, from 0 to 2. And if I take -1, it's positive. Take 1, 1, this is positive, this is negative, so it's negative. Take 3, positive. This is always positive. 3 minus 2 is positive. Take 10. This is actually always positive. Positive times positive, so it's positive. Yeah, now we have exponential, so we need to do different functions. The domain of f n numbers. We have no problem. Here also the domain of f or n numbers. So the function is continuous everywhere. Okay. So I need to find f prime. Be careful with the calculation. This is product rule. I have the derivative of the first minus e to the power x minus 3 plus 3 minus x e to the power x minus 3. Derivative of this is 1, so nothing to worry about. So I take e to the power x minus 3 as a common factor. I have what? Minus 1 plus 3 minus x. Yeah. Correct? Yeah. I took e to the power x minus 3 as a common factor. E to the power x minus 3. That will be what? 2 minus x. That will be f prime. Critical numbers. F prime equals 0. The function is differentiable everywhere. So I have x equal to. This is never be 0. So I will put the 2. Take a value before 2. Negative. 1 or 0. It will be positive. This is always positive, so that will be positive. More than 2, 3, that will be negative. Actually, the power is odd, so you need to change the sign. What he want? He want decreasing from where to where? From 2 to infinity, which is this. Okay. Now different function. I have len. Be careful about the len. What will be the domain of the function? Yeah, I need 4 minus x squared to be positive. So I have x squared less than 4. Absolute value of x less than 2. So x between minus 2 and 2. Yeah. This is my domain. Okay. Now we need to find f prime. That will be minus 2x over 4 minus x squared. Yeah. I need to find the critical numbers. Yeah, or this one I can rewrite it minus, yeah, I can leave it as this. Yeah, critical number, f prime equals 0. I'm getting x equals 0. So the number line I have, this is my domain. And the 0 is there. Yeah, the domain is minus 2 to 2. So this is what I will use in the real line. Okay, take a value between minus 1. This is my function. This is my function. Be careful, I have a minus sign. I take it as is. Minus 1, it will be minus times minus. 4 minus 1 square, minus 1 square, it will be positive. So I have positive. Now, more than 0, take 1. It will be negative over positive. That will be negative. What he want? Increasing. Increasing, it will be from where to where? From minus 2 to 0. Yeah. This function, yeah, need to be careful about the domain to start with. What's the domain of f? I need two things. I need x from this. I need x is positive. And from this, I need 1 minus ln x is positive. This is the argument of the outside len. I need to solve this. This is very clear, but this one, I have ln x less than 1 is increasing function, so I can take e. It will be x less than e. Take e of both, x less than e. So I have 0 and e. I have the function is greater than 0 as less than e. So the domain of the function from 0 to e. The domain of the function from 0 to e. So this is what I will work out. I will work out with this. Now we'll need to find f prime. F prime will be what? 1 minus ln x, since I have this ln of something, times derivative of this, derivative of the denominator, this one, which is minus 1 over x. So do the calculation. That will be minus 1 over x, 1 minus ln x. Okay. So this is f prime. So I need f prime equals 0. I'm getting nothing. So what I will do, I just list the interval. This is 0. And this is e. I have no critical numbers. Okay. So take a value between 0 and e. Take 1. Will be minus. This is minus. This is positive. 1 minus ln 1, which is positive. So I have negative. So the function decreasing everywhere when its domain, which is 0 to e. Okay. Now I have two problems to go. Here I have, what is this? F of x. Let me rewrite it. Ln x over x squared. So the domain of f or real numbers. Oh, no. The domain of f is what? X is positive. Okay. X is positive. So this is in the border. No need to worry about it. So I need to find f prime. Yeah, take it as a power. Easier. It will be minus 2. X is minus 3 ln x. Plus x is minus 2, derivative of ln, which is x is minus 1. So I can take x is minus 3 common factor. I have minus 2 ln x plus 1. Okay. Which is, I can rewrite it, 1 minus 2 ln x over x. So this is my f prime. Don't forget the domain from 0. So this will be the border. Okay. So I need the critical numbers. F prime equals 0. I'm getting what? 1 minus 2 ln x equals 0. So I have 2 ln x equal 1. So I have ln x equal half. Take e. I have x to the power e to the power half, which is square root of e. That will be my value. So I'll make the number line starting from 0. This is the border, okay? And this is square root of e. That's it. Now, I need to take a value before the square root of e. I take 1, plug it here. I have what? 1 minus 0 over 1, so that will be positive. Take a value more than square root of e. Take e. I have 1 minus 2 times 1, which is negative, over positive. That will be negative. And what I want, increasing. Increasing will be from where to where? Very clear. From 0 to square root of e, which is this one. Yeah, remember I took a value here, x equal 1. I know 1 is less than this. Here I take a value, x equal e. So you can easily check it. This is the last one. What is new? He gave you f prime. So no need to do any. He gave you f prime. خلاص. Now it's ready. We need to check the signs of this. But be careful. This one is always positive. So we cannot find the 0. And this one is always positive. Because if you want to find the zeros of this one, you are getting the delta, which is b squared minus 4ac, is 1 minus 8, which is negative. So you have no real zeros. Real zeros. This is always positive also. We can check it. Actually, you can think of it x squared plus x. If I add the coefficient, half of the coefficient of x squared, which is 1 over 4. So this is plus 2, so this is plus 7 over 4. So we have what? X plus half all squared plus 7 over 4, which is always positive. So this is also always positive. So I need to consider this. So critical numbers, x equal 2 and x equal 1. Plug it. 1 to 2. Yeah. Take a value before 1, 0. This is always positive, always positive. So you have negative times negative. That will make it positive. Since the power is odd, 1 and 3, so just change sign. Yeah, I finished problems about decreasing and increasing. Then I will do another video where I will do the local extrema, local maximum, local minimum. I stop the recording. Thank you.